we're going to let the 2022 scholars wow us with the work that they have done over this last year. And with that, I'll share my screen, and it has the slides from the presenters, from the scholars. And then when you're up, you can just have us walk us through what you've done. I do want to just encourage everybody to be aware of time, since there are 8 different presenters and you all have lots to share. But if we can try real hard to keep it within the time frame, so that our guest presenters got plenty of time at the end. So let me go ahead and share. And actually, no, I didn't do this. Give me a second to share the sound. Okay. So what we'll do, Cubes lessons. All right, so look, Jabari, looks like you are up. Why don't you go ahead and take it from here?
Cool beans. That's me. So I'm Jabari. I'm a PhD student at the University of Minnesota, geomorphologist. And the lesson that I came up with is about collecting geomorphic data, but also about learning to sketch in the field and thinking about the ways that our perspectives influence what we see when we're out in the field. And so it's sort of a modular, the idea is that the lesson is very modular, where there's sort of this sketching activity before and after kind of field data collection. And the idea is that presumably after collecting this geomorphic data, they will see the stream system a little bit different than they did when they first got there and did this initial sketch. So you can see the learning objectives there. Some of them are about the sketching part of things. Some of them are about the data collection part of things. And then also the sort of reflective component of thinking about how their perspective influences what they see. So we can go to the next one. So walking through the actual lesson itself, the part that's outlined in red there is the sort of science piece in the middle. And in my idea is that you could substitute in some other science component. Mine is about geomorph, but if you wanted to collect and measure fish, you could do that in the middle as well. But going from left to right, top to bottom, you get to your site, you sort of give this initial overview about sketching in the field. We're drawing as a data source rather than trying to create the most beautiful picture of what we can. There's a timed drawing activity. So they go in increments from a longer period to a shorter period, where they're trying to communicate the same visual information in 10 minutes, and then 4 minutes, and then 1 minute. And then students have the opportunity to share those drawings to see if different people are noticing different things, even though we're all at the same field site. And then we break the students up into teams, and we've got these different geomorphic data that we're collecting. So river discharge is in that picture on the left there. Grain size is that picture in the middle. I think the one on the right is also showing discharge. I guess on the left is us explaining how to use the equipment as we're first getting the students situated in their spots. So then you spend time collecting the data, and then at the end, you come back to the sketching activity again, and you have the students try to go back to the same spot that they were at initially, and you have them redraw the field site after having done this data collection. And again, the hope or the thought is that perhaps after doing this data collection, thinking more intensively about the site from a particular scientific perspective, they'll be looking for slightly different things as they're sitting there and sketching. And then there's also some calculations to be done based on the data that was collected that you could do in the field, or if you're going to go back to a classroom, it could be a part of the lab that you're doing later to be turned in later. So you can go to the next one, which is just the reference. So it's up on Cubes. You can see all the tags there. So geomorph, sketching, discharge. Of course, the River Field Studies Network, you can find all of our lessons there. And I guess I'll hand it off to whoever's next.
Thanks.
Thanks, Jabari. Yeah, so next it's me, Danielle Hare. I'm just graduated from the University of Connecticut. And my lesson for Cubes and for this network was thinking about how we can identify groundwater discharge and think about what that means for a stream habitat assessment. So really trying to link these ideas of how do we measure groundwater discharge, or just identify where groundwater is coming in, and what does that mean in a larger landscape context, but also what does that mean on this smaller, maybe patchy scale stream habitat assessment. Next slide, please. And so it's based around 3 objectives, and so there's 3 different components of the lesson. Yeah, so centered around each of these objectives. So the first objective is to encourage context-based learning. And what I mean by that is really that landscape piece, really trying to think about trying to center students to place where they are, the context of where they are, the land use. So thinking about as they arrived on the site, what does it look like? What does the riparian buffer look like? But beyond that, what does the actual watershed look like and beyond? Essentially centering the students to think about how groundwater could be influenced and ultimately then how that would influence streams. Next, please. And then so the second is then how do we identify where groundwater is coming into streams? So how essentially looking at that connection between land use beyond the riparian buffer and thinking about how that might be influencing streams and then identifying where these are coming in using a bunch of different methods. So I kind of try and make it flexible. I'm very familiar with using thermal infrared to identify groundwater seeps. And so that was kind of my main focus, but we also use just water quality sensors as well as some kind of location samples. And then, sorry, yeah, next. And then ultimately, the final objective is thinking about how we can, what these results mean as far as within our research. So how would we design sampling regimes to make sure they're capturing groundwater discharge or making sure that that's not influencing our sample too much, especially thinking about if there's land use and capturing that. And then last slide, Andy. So just some reflection points for you guys going into doing this, some things that I wish I did or thought worked well. Taking advantage of the background information or baseline, trying to make sure the students are kind of up to speed before we get out there and do the practice one. Sounds straightforward, but could have made better use of that. Aligning with other students, I definitely would encourage people to work together and I think it enhances the experience. And then also thinking about providing differentiation as far as different types of educators specifically, but also different types of students. I'm really trying to think about that, as well as think about what would be, what videos or pictures would be really nice to have in your cubes that you could collect during your practice session. I know that I could have done a better job of that. And I'll pass it off there though.
All right, thank you.
Luke Ward here. Based on Danielle's point about working with people, I do want to thank Jabbar and Danielle for feedback on my particular lesson. It was really helpful. This lesson in a nutshell is about using the Survey 123 app to gather spatial data about physical habitat characteristics. And can you hit next there, Andy? As spelled out in the Environmental Protection Agency's National Rivers and Streams Assessment manuals. I kind of integrated the weightable and non-weightable manuals. In a nutshell, I built a little Survey 123 app that you can access via cubes as an XML file, and then you can adapt it to your own river that has information from, or it's set up to gather information from one little subset, Appendix B in particular, of the NRSA Field Operations Manual. And the goal is that students learn to use this sort of geospatial technology to gather information about how humans are affecting the watershed in question. And so here you can see the learning outcomes here. basically be able to demonstrate the ability to use survey 1, 2, 3. Kind of start to think critically about the degree to which these standardized protocols for understanding human impacts and disturbances are viable, and maybe capturing everything that students experience on the river, and then use field observations to communicate how spatial resolution and classifications systems associated with the NRSA and Survey 123 app can sort of shape our understandings of riparian habitat quality. Go ahead and hit next there, Andy, if you don't mind. And then you can just blast through a couple next here. There's some animation. I didn't think about that. So there's basically 3 steps. The first thing that, if you're interested, or for users, is that they will have to be willing to either learn Survey 1, 2, 3 or have a working understanding of it. And then they'll probably have to tinker with the downloading and installation of the app. I have some support documents and some text in my lesson as well. Once Survey 1, 2, 3 is installed on devices, then I suggest dividing your student groups out, or your, participants into teams, assign them data collection assignments. There's some discussion in descriptions in the lesson of how to organize. I see that question about Survey 1, 2, 3 and QGIS. I know, yeah, Esri. This is Esri intensive. QGIS is working on things like this, as far as I understand, but it's not quite as, let's say, seamless-ish as the Esri platforms are. And I do promote a safety talk as part of that. Go ahead, Andy. Click a couple more there if you don't mind. The next step is to go out in the field. There's a sketch of sort of the reaches of the amount of, there's different ways you can break up wherever you are on the river into study areas and kind of into transects, and then do data collection. These students are actually doing a burrito collection here on the river, but it kind of looks like that guy's doing data collection, so I put it in. And they are on their apps, using the pick lists, and hit it one more time or two, will you, Andy? And so there's a kind of a look at how that looks. And these, yeah, burrito data is the best kind of data. Agreed, Jabari. How this interface looks on an app, and the language and phrasing and the opportunities to assign, or to just, I guess, the data that you can collect, the way you collect that data is very similar to how it's organized on the NRSA document. So you can kind of get a view of that. And then there's some reflection activities I compose. This is my favorite kind of reflection, is kind of campfire sessions, and then hit it one more time there, 2 more times, one and then another. But what's nice is you can, if you do have an opportunity to get access to GIS Lab, or just online access, you can sort of use the geospatial technology to explore patterns in the data. And then one more, Andy. I think you got one more. Click, go ahead and advance a few more. Yeah, hit it again. And so these are, you can just kind of pop through these, just, maybe take a second each. These are just pictures of students kind of either using Survey 1, 2, 3 or about to use Survey 1, 2, 3 on the Missouri. Go, keep going here. Keep a couple more, keep them blasting through there. Yeah, there, one more. And then here's, there is the cubes view there, and you can see all the various tags. Yeah, in terms of accessibility, there are a lot of limitations with this particular software. I did also, for the scholar strip, I have a kind of an image analysis based version of this where you're using air photos that I plan to put on Cube. So it's very similar workflow, except instead of using Survey 1, 2, 3, you're actually annotating imagery, and that's how you're doing the data collection. So I am trying to make it more accessible. That's it.
All right. Thank you, Luke. Sarah.
Hi, my name is Sarah Gordon. I am a science faculty member at Colorado Mountain College at Spring Valley, which is just in Western Colorado. I kind of consider myself more a science, well, definitely, not kind of, I definitely consider myself more of a science educator than a scientist. And I am an active teacher, active faculty member. So I have environmental science classes and biology classes. And so when I became a river scholar in this program last year, I let my students help me choose what the lesson was going to be about. And my environmental science students were very passionate in their choice to study microplastics. So that's how we ended up on riverine microplastics. Through my creation of this lesson, I discovered really quickly that it's pretty complicated, and the chemistry and wet lab component of microplastic research is not something we can do in the field. So I'll briefly talk on the next slide here in a second about a couple of adaptations I made. But my objectives for this were to help the students develop a real world understanding of scientific inquiry. So this lesson helps students because I kind of used the scientific inquiry and the scientific method as the scaffolding to talk about microplastics. And so the whole lesson itself is kind of starts from the beginning with observation and exploration of the landscape to all the way through collecting samples and processing samples and talking about their results together as a group. So that's why my first objective is very specific to the scientific inquiry. Objective number 2 was obtain an increased sense of real world understanding and personal connection to microplastics. Because not only connecting that understanding to local pollution, which here in Western Colorado is actually our laundry, because we have so much outdoor gear that we wash. And then we also get a lot of atmospheric deposition here as well. So I wanted students from anywhere in the world to be able to connect to where their local microplastic pollution is coming from. And then also be able to connect their lifestyle to that microplastic footprint and realize not just the local scale, but at a global scale. And then the third objective was to help them gain confidence in river-based scientific field skills. And so to really help them with feeling comfortable with observation skills when they're out in a very distracting, sometimes overwhelming location, especially for people who aren't innately comfortable being out in nature. And then also help them develop experiential knowledge about field science and practice, and just help them feel like a field scientist. Next slide, please, Andy. So there's actually 18 steps in the lesson, but I abbreviated this down for you to sort of just really briefly say that the students are given this opportunity to go out and explore and observe the location. And this could be from the shore, this could be in waders, this could be on rafts. We happen to have canoes, and that's how we did it in Virginia. But people were sent out to explore the landscape and actually look for trash. And I gave them a worksheet to try and tally up what kinds of litter they were finding, how old the litter looked like. And so then we used that to help the students actually through discussion and through the writing prompts. I asked them to form a hypothesis based off of where they think they might find microplastics in our location. So then we went out and we actually did grab samples. And this is based off some peer-reviewed research on some methods that work, and then actually created a field-friendly density separation technique using canola oil, so that we're not having to bring a lot of chemistry out into the field. And I even, for the river scholars on here that were in my lesson, I started off with glass, and I now have my lesson they're collecting in white plastic bottles because we don't want broken glass at the river. And we're not trying to find the nanoplastics or the really small clear plastics that would require mass spectrometry, mass spec. We're looking for the bright blues. You saw that video, the bright reds that have a very distinctive shape, and we can absolutely say, yeah, that definitely looks like a microplastic. So I thought, let's just use white plastic bottles, because that's not what we're looking for on the microscopes. We're looking for those bright blues and stuff. And then you end the lesson with the data analysis, kind of comparing the results from the different groups, different locations, kind of comparing their various hypotheses and what they think their conclusion was, and then opportunity to discuss and wrap up. Andy, one more slide, please. You can see here, we had the luxury of having this field location with a field building. I guess that's what you'd call it, sort of this open air building that we could store. We had electricity, so we could bring out some dissecting microscopes and plug in. But that's not necessary. The way I wrote the lab on cubes is designed to be on a river and doing it at a river's edge, all the way down to the microscopy. You can buy field microscopes for pretty inexpensive, or even just hand lenses that jewelers use. So that was really important to me, representing a rural college that does not have a lot of budget for lab equipment. And we definitely feel like kind of like this little step siblings of big institutions. It felt really important to me to write a lesson that anybody could do with some really basic equipment and supplies, really inexpensive, and to just get out there and really feel this connection to this kind of pollution. Last slide, please, Andy. So here's my landing page for my lesson and my, I guess my citation down there. So thank you.
All right, thank you, Sarah. Susan and Liz.
All right. So I'm Liz Waring. I am at Northeastern State University in Oklahoma. And this was actually a two-part lesson. So I did this along with Susan Washko, who couldn't be here today. So I'm going to take up presenting. But she took care of the first part of the lesson, and I did the second part. But so we made a two-part lab looking at detritus-based food webs in streams. So, part A, focusing on the detritus itself and the different kinds of detritus that you can find in a stream. And part B was focused in on the macro inverts. So we, have a lot of learning objectives here. Some are pretty basic, learning the terminology like detritus, invertebrate, benthic. I have an ellipsis there because it's whatever terminology you want your students to learn, and know the type of equipment used, depending on what kind of macro invertebrate or detritus you're looking at, comparing quantities of them, and then learning about the macro inverts themselves. But rather than reading words, which we do enough of in our daily life. Can I see my next slide? All right, so the detritus part, like since for the rendezvous, since we had a limited time, there was about 24 hours in between the parts, but it really is designed that, if you're teaching like a weekly lab, you could put stuff out one week and come back the next week. But it started, in the upper left-hand corner there with Susan very enthusiastically explaining what detritus is and decomposition and death to everyone, and various types of detritus. We spent a lot of time in that creek that was near the field station, collecting different types of detritus, taking it up to some picnic tables, sorting through it, and then of course making the classic litter bags that we deployed into the stream. Next slide, please. And then the second part is, macro inverts. Who are they? What do they want? Why are they here? So we collected our litter bags and took them up to some picnic tables again to sort through them. I had brought along, I just happened right before this, the rendezvous, to get some sort of materials, like you can see on one of the picnic tables, there was a poster that had some line drawings of macro inverts to try to help students who had not been introduced into macro inverts before, about the different orders. Then we went back to the stream and tried a couple different techniques, like using these D nets to sweep net for macro inverts. We found that giant hellgrammite, and then went back and drew our favorite macro that we found for the day. So that was, the lesson itself is kind of a classic lesson, but the two parts of combining the decomposition and detritus part, plus then going back and looking at the macros. And then if you could just go to my last slide. So this is just our lesson itself, that is up on Cubes, and the citation for it. But yes, oh yes, I did. Thank you, Elise. The Stroud Institute also has a Pocket macros app now that's actually really great for identifying down to order. In particular, they have a lot of great images on there. And it's not a huge app. It's not going to take up a ton of room on their phone. It's great for the East Coast. They're working, I think, on some of the Western ones more. But yeah, thank you, Elise. And that's it.
All right, thank you, Liz. Aaron and Elise.
Hi, everyone. I think I'm going to be the voice for The River Breathes. I'm Elise Chapman. at UT Chattanooga. And Aaron and I were interested in designing a field effort that would enable students and encourage students to explore integrative processes in ecosystems. Generally, we've found it more tractable to have organismal-based focus. And so we were excited to contribute an integrative measure kind of approach to a field lesson. And so our goal with this lesson is to reduce some of those barriers. And our hope is that this can act as sort of a capstone or close to capstone field experience that integrates lots of the other work that you've done with field lessons in your course up until this point. And so we're looking at reach metabolism and encouraging students to think about how both production and respiration impact dissolved oxygen concentrations in the water column. And this was a collaborative effort with Aaron Koning, who's at University of Nevada, Reno. And we got a lot of support from Andy, Jabari, and Danielle on edits. So thanks to those people too. Could you get me the next slide? We have a multi-step lesson, but the goal here is to alternate times where students take a leadership role in their learning. And so we want to initially connect them to the concept of metabolism and how they are metabolically active organisms. And as a whole system, rivers exchange oxygen with the environment, and that there are different organisms that are driving that sort of as an integrative process. When we were at the rendezvous, we linked it to the river continuum concept and had their reflection largely based on that. And so that's the first image here. The way we wrote up the lesson, though, is we shifted to thinking about how they breathe and use gases and exchange gases, and linking that with the idea that the river breathes. So that's how we wrote up the lesson. And then we would echo Danielle's point about the more foundational background context information you can provide before you get into the field, the better we think this is going to go. But in our rendezvous lesson, we were pretty heavy on content delivery in the field. So that's that second image there. And specifically, we provided reviews of productivity versus respiration, autochthonous and allochthonous inputs that drive ecosystem metabolism in rivers. And so this does link really nicely, like the mini lessons, including the one we just heard about. The next step, the students take charge again and are encouraged to generate at least a prediction, if they want a formal hypothesis, based on this background content about where they think they'll find high and low dissolved oxygen concentrations in their study reach. And so they break out into groups. This would complement nicely with a field sketching lesson or some measures of discharge or basic field geomorphology kind of work, depending on how many dissolved oxygen probes you have. And so each group would have a probe, and when they have use of the probe, they'll go around and find areas with high and low dissolved oxygen. And when they don't, they'll be doing some other activity. Then they come together and based on that information, talk about proper deployment for an actual diel or 24-hour curve, or deployment for a dissolved oxygen curve. And then they'll deploy. And before you leave the field site, we encourage, can you advance the slide, Andy? And so here in the top, we encourage before you leave the field site to enhance this in a time and space kind of way using a dissolved oxygen curve matching game that Aaron's designed using stream pulse data. And so you can see students are given, in this case, we gave each group 3 site images with an inset global map, so they know globally where their study site is, and a diel dissolved oxygen curve to enhance a discussion about the landscape level drivers of ecosystem metabolism and dissolved oxygen in the water column. And so they match these so that even though they're just doing it at one point in time and in one location, they have that perspective of a landscape scale drivers of ecosystem metabolism. Depending on your needs and your students' capacities, you can collect the probes or have another field visit to complement with another lesson to collect the dissolved oxygen probes. But there does need to be at least a 30-minute data analysis lab that follows up our lesson. And we've included in our lesson a fillable Excel spreadsheet. As is, it will automatically calculate these dissolved oxygen curves for you and convert those to grams of carbon per day if you're interested. But based on what you would expect from your students, you can, of course, pull this out and then just provide directions for them to do it themselves. Again, based on student need and your desired outcome. Next slide. And so that's our lesson, and you can find our citation and DOI here. And I'm finished unless Andy has any, or Aaron has anything.
No, that was great. Thanks, Elise.
All right, thanks, Elise.
So I am next. My name is Mary Beth Niffen, and I had the title of the lesson that I taught is a STEAM approach to investigating the hydrologic cycle. And I've actually modified this somewhat from the original, what I taught in the field. But it is the same overarching sort of premise. The point is to teach students how to make detailed field observations and then transform those into a hydrologic conceptual model using paint, or with the painting medium. So it's really integrating observation and then conceptualization and then communication. So you can advance the slide, please. So there's 3 parts. The first part took place in sort of before the actual lesson on site, and that's the field observation and field notes. And so that's piece 1. Piece 2 is a discussion and lecture, and then the painting practice. And then part 3 is a reflection and more of a written work and a little more research on the local hydrology. So next slide, please. The learning outcomes are really improving students' ability to make detailed field observations and to be able to understand the hydrologic cycle and specific processes of the hydrologic cycle, to also integrate art and science, and to be able to develop their understanding of a process into a conceptual model. And that this can be a precursor for teaching modeling or like computer modeling in the future. Next slide. And so the first piece is, like I said, taking field observations. There should be a number of different field observation times that I'm suggesting a 20-minute minimum for each one. So students would focus on either condensation, precipitation, evapotranspiration, infiltration, or runoff, and really observing the one or several of those processes in their notebooks. Next slide. And then coming together and doing a comparison of art and science data collection methods. And then the lecture is focused on those different topics that I have listed under lecture concepts. But overall, it's teaching about how do we understand, and then how do we put that into a model and then and draw it out to increase our understanding of any given topic. Next slide. So here's some examples of people painting. And in my instructions, I somewhat, I think, improved my instructions for painting prompts. And I'm encouraging people to think about the canvas as a control volume, where you can think about what's going in and out of your canvas as part of this hydrologic process. So yeah, next slide. And then the last part is a written reflection. So students can write about how they understood their field, or what they learned from like detailed field observations, how the painting practice informed them, and how they learned more about the local hydrology. And next slide. So it is a really good opportunity to introduce students in science to, linking to art, because creativity is a really important part of science, and breaking the myth of some people are left brain, right brained, or, analytical or emotional, just breaking those cultural barriers was really one of the key pieces I was trying to communicate. And that this type of exercise could be applied to other concepts besides the hydrologic cycle. Next slide. And then this is just the citation and the page. And that is it.
Thanks, Mary Beth.
Hello, everybody. So I'm Zbigniew Grabowski, or Zbig or Z. I'm currently an extension educator in water quality at the Center for Land Use, Education, and Research at the University of Connecticut. I was really excited to partake in the whole RFSN exercise, and I struggled a little bit with this module to translate a bunch of ideas I've had with kind of a cohort of folks around complex systems and how to apply that in a field setting. So this module that's come up, it's meant essentially to serve as a overall reflective or capstone type activity on a field course. And I want to link it to a number of different things you've heard about today. So the idea is to expose students to this idea of complex systems, and particularly look at rivers as social, ecological, technological systems. So co-produced through social, ecological, and technological drivers, and then apply that understanding in a collaborative problem-solving exercise. So collaboratively framing issues and coming up with an actionable agenda that can include the creation of more scientific knowledge, but really trying to, in line with the goals of the RFSN, make students more active, scholar actors in the world, and river advocates. So that kind of high-level goal is to understand river processes as resulting from these complex system interactions, and then apply it in a reflexive and integrative collaborative manner. That's me sweating it out and trying to explain sets theory in the field. Next slide, please. So the overall kind of approach for folks familiar with kind of problem-oriented learning was to provide for the instructor to use sets to kind of prime students and frame the discussion around why is the river the way it is. And this, kind of, as you can see in this kind of first picture on the top left here, the instructor is really playing a somewhat central role in bringing together information, and the module is set up to kind of provide a structured way of bringing together diverse sets of information and presenting that to students to kind of give them a common framework or understanding of why the river is the way it is, breaking it down into social, ecological, technological dimensions. The next step is to kind of discuss and elaborate and bring knowledge that maybe the instructor hasn't found over the course of their kind of own research, their understanding, to collaboratively enrich an understanding of why the river is the way it is in a large group setting. And then the next step, drawing on kind of interdisciplinary research methods and learning methods, is to have students identify their own expertise and orientation, kind of similar to their positionality, but have them self-reflect on what type of knowledge and methods they're bringing to the table here, and then to sort them kind of along those axes. If it's a really large group, this is a way to kind of partition groups to make sure there's a kind of equal division of different disciplinary expertises in different groups. If it's a smaller group, it's basically a way for people to share their orientation, budding expertise or maybe well-developed expertise, and to discuss what they bring to the table. And the final kind of stage of this exercise is to collaboratively identify and prioritize drivers of river conditions that can be addressed through actions. So we're kind of moving from, again, kind of like a, lack of a better word, loading dock kind of model of, the instructor is conferring expertise on the student, to one where at the end they're collaboratively engaging in framing the issue, understanding its major drivers, and then choosing to kind of dig deeper into 1 or 2 or 3 maximum sets of actions that could be used to actually address river conditions. There's a lot more details in the module that's posted, and I'm really excited to hear our guest speaker. So on the last slide, you can see the full name of it. Here it was a draft because there were some cubes issues, but it's posted now. And so folks who are interested in applying complex systems within a field setting, which has been mentioned, really, I think adds to students not just seeing the river in an abstract way, but really focusing on experiential learning. This is one attempt to do so. So thanks everybody for your attention.